Have you ever opened a Python file written by a senior engineer and immediately felt calm? There's nothing flashy, no clever tricks, no unnecessary complexity. But somehow, you trust this code. That's because senior engineers don't write code to impress computers. They write code to help humans think clearly. In this video, we're going to break down how senior engineers actually write Python, and more importantly, how they think while writing it. Hey everyone, welcome to BinaryBros Tech. We share Python tips that make you faster, not just clever. No theory dumps, only things you can use today. Let's jump straight into tip 1. Let's look at this code. This code works, there's nothing technically wrong with it. But notice what your brain is doing while reading this. You're tracking the index, you're mapping items back to the list, you're holding extra information in your head. Senior engineers notice this mental overhead immediately, and they try to remove it. Let's look at the senior rewrite code here. Same logic, same output. But now the intent is obvious. A senior engineer asks one question here: how fast can someone else understand this? And clarity always wins. Let's look at this poor naming example code. The computer understands this perfectly, but humans don't. What is data? What does process actually do? Senior engineers think about the next human reading this, not the machine. Now let's take a look at this example, which shows how senior use naming. Now the code reads like a sentence. No comments needed, no guessing required. Senior engineers use naming as documentation. This is how seniors reduce bugs, by removing ambiguity before it becomes a problem. When code is deeply nested, logic gets buried. Your eyes move inward, your brain works harder. Senior engineers want the happy path to stand out immediately. Now let's look at this early exit example code instead of the nested code we saw. This looks longer, but it's mentally cheaper. Senior engineers exit early to flatten code. Less nesting means less confusion. This pattern appears everywhere in junior code. And again, it works. But senior engineers don't stop at it works. They ask, is this the clearest and safest way to express this in Python? Manual indexing forces the reader to mentally connect I back to items I. That's extra cognitive load and extra opportunities for off-by-one errors. Seniors know that when the language already provides a tool for clarity, using it isn't laziness, it's professionalism. Now look at this. We don't manage the index, we don't look up the item. Python handles the pairing for us. This removes a whole category of potential mistakes. But more importantly, it communicates intent instantly. I need both the position and the value. Senior engineers trust built-ins because they're tested, optimized, and universally understood by other Python developers. That shared understanding is what makes code bases scalable. This is how humans naturally think, loop until something is true. But senior engineers recognize patterns like this immediately. They've seen them hundreds of times, and they know Python has already solved them. When you rewrite common patterns manually, you increase surface area for bugs and hide the true intention of the code. This reads almost like English. And that's not an accident. Python was designed to be expressive. Senior engineers don't try to outsmart the language. They let the language do the heavy lifting. Because fewer moving parts means fewer bugs, fewer misunderstandings, and easier reviews. When two pieces of data belong together, senior engineers make that relationship explicit. Instead of manually indexing two lists, zip binds them together safely and clearly. If the lists ever get out of sync, the problem becomes visible immediately. This is a pattern you see again and again in senior code. Make relationships obvious and let the language enforce them. Junior engineers often write code based on what's true today. Senior engineers write code based on what will break tomorrow. Hard-coded logic like this spreads business rules directly into behavior, and every time a rule changes, you have to edit logic, which increases risk. Seniors try to isolate decisions from actions. Let's look at the updated example code. Now the rule lives in data, not logic. If the business adds a new role, you update a set, not a conditional tree. This reduces the chance of introducing bugs while making updates. Senior engineers design systems where change is localized, predictable, and low risk. Now let's look at this configuration example. This is a powerful senior level habit. Instead of embedding pricing rules across multiple if statements, you centralize them in configuration. Now the code doesn't change when the business changes, only the data does. That separation is what makes systems flexible instead of fragile. In this example code, this comment repeats the code. It doesn't add information, it adds noise. Senior engineers know that every comment is a liability. If the code changes and the comment doesn't, the comment becomes a lie. Let's look at a good comment example. The comment here explains purpose, not mechanics. The what is obvious from the code, the why is not. And over time, the reason behind a decision is the first thing teams forget. Senior engineers use comments to preserve intent across months and years. This is senior level commenting. It captures context that isn't visible in the code, a production behavior, a system limitation, a hard-earned lesson. Without this comment, a future engineer might remove the retry logic, thinking it's unnecessary. Senior engineers write comments to protect future teams from repeating past mistakes. Senior engineers don't write clever code. They write code other humans can understand, quickly, confidently, and without fear of breaking things. Because great engineering isn't about showing how smart you are. It's about making the next person's job easier. Clarity builds trust. Trust makes teams faster. And maintainable code is what allows software to grow over time. So next time you write Python, don't ask, is this impressive? Ask, is this obvious? Is this safe to change? That mindset, writing code for people, not just machines, is what separates junior developers from senior engineers. If this helped you level up your thinking, subscribe to BinaryBros Tech for more real-world engineering lessons. And remember, clean code isn't about perfection, it's about respect for the next person who opens the file.